Well, students, today we are going to continue the last class that we were trying to learn the multiple projects and constraints. This is what was the topic that we were trying to understand in the last class. Uh, Last class we have solved one problem on this particular topic, and similarly today also we will try to solve one more problem on the same topic. So let us continue. Let me read out the question for you, and then followed by we'll solve this question. There are five projects M, N, O, P, and Q are available to a company. These are the five projects that are available to a particular company. Okay. So there is an initial investment to all these companies. There is annual cash flow, life of the project is given, salvage value is given, and then project N and Q are mutually exclusive. Otherwise, projects are independent. If the cost of capital for the firm is 12%, which project should be chosen at the budget levels of rupees 3 lakh and rupees 3 lakh 50,000? Assume that the decision criterion is the net present value. Use the feasible combination approach. So this is what is the question given, and let us try to find a solution for this. Let me put across the important data of the question on the board, and then further let us try to solve this problem. There are five projects okay. The data of these five projects are: the first one is initial investment, the projects are M, N, O, P, and Q. Okay, so for the M, project M, the initial investment is rupees 20,000, and for project N it is 50,000, and for project O it is 85,000, and for project P it is 90,000, and for project Q it is 1,50,000. Okay, so the annual cash flow of these projects are: for project M, annual cash flow is 5,000, and for project N it is 10,000. For project O it is 20,000. For project P again it is 20,000. For project Q it is 25,000. Next is life of the project. So the life of the project, this is in terms of years. In terms of years, it is given. So this is 8 years, project N is 9 years, project O is 6 years, project P is 6 years, project Q is 10 years. Okay. Next one is the salvage value. Salvage value is 6,000. Salvage value of P is 20,000. Salvage value of Q is 40,000. So this is the data given. Let us move on and try to put across some more important data that is given. Point number 1, projects N and Q are mutually exclusive. Are mutually exclusive. Okay, so otherwise the projects are independent. The cost of capital is 12%. The budget levels given are rupees 3 lakh and rupees 3,50,000. So these are two budget levels that is given in the problem. So we have to use NPV method and find out the solution to this particular problem. Okay, so let us go ahead and try to solve this and find out using feasible combination approach which will be an ideal project out of the given data. Okay, so moving on, let us solve NPV of the projects. The NPV of the projects are let us take NPV for M, for project M. So for project M NPV, the annual cash flows are 5,000 into present value interest factor annuity. You can refer the table and find out the annuity value. The cost of capital is 12%. and the life of the project is 8 years. So the discount rate for 12% for the period of 8 years plus the net salvage value given in the question is 6,000 into present value interest factor for 12% for 8 years minus 20,000 the initial investment of the project equal to, so you will get an answer of 7,264. Next, we are going to solve the NPV of project N is equal to 10,000 into present value interest factor annuity at 12% for 8 years, sorry, for 9 years. The project N is 9 years. The life of the project of N is 9 years. So 12% for 9 years and we don't have any salvage value for this particular project. So straight away I am going to deduct the initial investment for this project, that is 50,000. So you will get an answer of 3,280 as the net present value for project N. Now let us take net present value of project O is equal to 20,000 into present value interest factor annuity for 12% for 6 years minus this also does not have any salvage value. So we will deduct the initial investment straight away, that is minus 85,000, and you will get an answer of minus 2,780. Okay. So similarly, next project is project P. So NPV of project P is equal to 20,000 into present value interest factor annuity at 12% for 6 years plus salvage value is there for this particular project, that is project P. So 20,000 into present value interest factor at 12% for 6 years minus the initial investment, that is 90,000. Okay. And then the last project is project Q. NPV of project Q is equal to 25,000 into present value interest factor annuity for at 12% for 10 years plus there is a salvage value of 40,000 for this project. 40,000 into present value interest factor annuity at 12% for 10 years minus 1,50,000. So the answer for this will be is equal to 4,130. So for project P, this is the details. So answer for project P is 2,360. Okay. So for project P, the answer is 2,360. For project Q, the NPV is 4,130. For project O, the NPV is negative, that is minus 2,780. And for project N, the NPV is 3,280. For project N, the NPV is 7,264. So let us move on. Let us make a feasible combinations. Okay. Since in the problem we find that the project O is negative, the NPV of project O is negative, and hence we are going to straight away reject the project O. Okay. And we will continue further. N and Q, as mentioned in the problem, are mutually exclusive. That means we are not going to select these projects together at a time. So either we can choose N or Q. Okay. So keeping these things in mind, let us go ahead and make a feasible combinations available for us. Okay, so let me put a combination. Okay, this is outlay, that is the initial investment, and here I am going to write NPV for these combinations. Okay, so the first one is project M. As it is, we will note down N. O I am not going to consider because the NPV of O is negative and I am going to reject that project. So I am not going to consider it for calculation or for feasible combination approach. Next one that I am going to consider is P, and then Q I am going to consider. Then M and N I am going to consider. Then I will be having M and P as a combination. Then I will be having M and Q as the combination. Next I am going to have N and P as the combination. Next I will be having P and Q as the combination. Next I will be having M, N and P as the combinations. So these are some of the combinations that are available to us. So M, the outlay will be 20,000. Next, the N's outlay is 50,000. Okay. P's outlay is 90,000. Q's outlay is 1,50,000. M and N outlay is 70,000. M and P outlay is 1,10,000. M and Q outlay is 1,70,000. N and P outlay is 1,40,000. P and Q outlay is 2,40,000. M, N and P's outlay is 1,60,000. Okay, so these are the outlays available to us. So if you just look, how did I get the outlay for M and N? So you just need to pick up the outlay of the M and N. M's outlay is 20,000 and N's outlay is 50,000. Add both of these two values, 20,000 plus 50,000, you will get 70,000. Similarly, M and P outlays 20,000 plus 90,000, so you will get 1,10,000. Similarly, you add for project M and Q, N and P, as well as P and Q, and M, N and P. So if you add their outlay, so you will get these values as the outlay for these combination of projects. Okay, so next let us see the NPV of these projects. So project M, I will get an NPV of 7,264. For project N, I am going to get an NPV of 3,280. For project P, it is 2,360. For project Q, it will be 4,130. And for project M and N, the NPV will be 10,544. And for project M and P, it will be 9,624. For project M and Q, so it is going to be 11,394. For project N and P, it is going to be 5,640. For project P and Q, it is going to be 6,490. And for the projects M, N and P, it is going to be 12,904. So these are the feasible combinations available for the project, and if you just look at the maximum number of projects that we could see in the combination is M, N and P, for which we get a net present value which is the highest, that is 12,904 at the minimum budget level, that is a minimum investment level of 1,60,000. Okay, so this is the most feasible combination that we can have in this particular problem. Okay, at the budget level of 3 lakh as well as 3,50,000. So this is the project that we can say that M, N and P is the combination that suits the best in this particular problem. Okay, that's all on multiple projects and constraints. Let us move on to the next part of the problem, that another set of problem in multiple projects and constraints. So we are going to understand. We have learned a concept in operations management or quantitative techniques as well. The problem of linear programming, the linear programming problem or a linear programming formulation. This is a mathematical model we are going to use in capital budgeting problems. So this is another very famous model, that linear programming problem, LPP we generally call it as. So this is a very famous a concept which is applicable in most of the domains in solving the multiple constraints. When there are multiple constraints and we have to select the best combination that will be helpful for us. So under such circumstances, there is a set of data that is given over here. Let me read out the data for you, and then we will move on and try to solve the problem. Since the question is very big, I cannot write it on the board completely. Maybe in my YouTube video, you can see the question at the beginning rather than my Impartus lecture. My Impartus lecture will only contain the solution part of this, but my YouTube video will contain the question as well for this particular problem. Okay. So let me read out the question for the people who are going to watch the Impartus video. A firm is evaluating 6 investment opportunities. Project J has got 6 projects. Project is denoted by J. Okay, so there are 6 projects, 1, 2, 3, 4, 5, 6. So these are 6 projects. Then the net present value of these projects are: for project 1 it is 8,000, for project 2 it is 10,000, for project 3 it is 15,000, for project 4 it is 20,000, for project 5 it is 40,000, for project 6 it is 80,000. Okay, and there are cash flows for 2 periods. Okay, cash outflow for period 1, or cash outflow in period 1. For project 1 it is 9,000, for project 2 it is 10,000, for project 3 it is 11,000, for project 4 it is 25,000, for project 5 it is 50,000, and for project 6 it is 70,000. Okay, and cash outflow in period 2 are: for project 1 it is 8,000, for project 2 it is 12,000, for project 3 it is 20,000, for project 4 it is 30,000, for project 4 it is 30,000, for project 5 it is 40,000, for project 6 it is 60,000. Okay, the budget available is limited to rupees 1,30,000 in year 1 and rupees 1,50,000 in year 2. Okay, so these are the 2 budget levels. Any amount not spent in year 1 can be transferred to year 2. The amount so transferred will earn a post-tax return of 6%. Okay. There are 2 additional constraints: power constraint and managerial constraint. Okay. The requirements and constraints applicable in this respect are project 1, 2, 3, 4, 5, 6, and for these 6 projects the power requirements are: for project 1 it is 3,000, for project 2 it is 5,000, for project 3 it is 4,000, for project 4 it is 8,000, for project 5 it is 10,000, for project 6 it is 20,000. Okay, and then managerial requirements are 10 for project 1, 15 for project 2, 20 for project 3, 25 for project 4 and 30 for project 5 and 40 for project 6. Okay. So here we have to develop or formulate a linear programming for this given capital budgeting problem. Okay, we are just supposed to formulate a linear uh, programming. Just we are going to put it in terms of the formula or the formulation. Okay, so we are not going to solve the entire linear programming problem in this case. Okay, so we will just formulate and leave it over there. Okay, so the higher mathematical models will tell us how to solve the operational models will tell us how to solve this particular linear programming problem. Okay, at our level we will just formulate a linear programming problem. Okay, and then we will leave it over there. Okay, that will be the formulation that we can have in this particular problem. This is the question. I will leave it over here and we will solve this. I will give you a solution maybe in the next class. Till then, I expect you to try out and try to find out about linear programming problem and its application in capital budgeting. I would request you to read the theoretical concept of this particular part in the textbook Projects by Prasanna Chandra. The details are given in that particular textbook, and then I will provide a solution for the problem that I have read out a while ago. Thank you.